So good morning. You are studying the serial communication of 8051. So we have discussed few points in last lecture. What is difference between serial communication and parallel communication? So advantage of serial communication is it requires only one line to transmit a data. So it is preferred for long distance communication. And in parallel communication, at a time you can transmit a 8-bit of data. In case of 8051, it depends upon size of data bus of controller or processor. So the data transmission is faster in parallel communication, whereas in serial communication, we are transmitting 1 bit at a time. So the transmission is slower. So for shortest distance, since hardware is complicated in parallel communication, for shortest distance, we prefer this parallel communication. Maybe both ICs are on your PCB, so we can prefer parallel communication. For long distance, we prefer serial communication. Then you know this different types of communications, modes of communication, simplex communication, that is one way data transmission, one device is transmitter and other is receiver. In half duplex communication, at a time only one device can transmit and other can receive. So walkie talkie is example of half duplex. For simplest communication, you can give example of printer. In full duplex, the data transmission and reception can be done simultaneously, like our telephone system. The communication can be in both directions simultaneously. So these are different modes of communication. Then we have discussed about asynchronous communication and synchronous communication. In synchronous communication, both devices work on the same clock signal. So there is no need of any format or extra things are not needed in synchronous communication because there is synchronization between transmitter and receiver devices because both works on the same clock. So along with data in synchronous communication, transmitter has to transmit clock signal also. So transmitter transmits a clock signal and data signal. So the example we can give as SPI protocol and I2C protocol. This you have to discuss, you have to study afterwards. In asynchronous communication, the both devices, receiver and transmitter, then they works on their individual clock signal. So separate clock signals are available for both transmitter and receiver, and transmitter only transmitted data. It will not transmit a clock signal. So both work on the different clock signal. But since it is a communication, there must be a synchronization between transmitter and receiver. Then only receiver can receive a proper data which is transmitted by transmitter. Otherwise, if a transmitter is faster, receiver is slower, so and there is no synchronization, then receiver may lose some data. So to make this asynchronous communication synchronize, some format is used while transmitting a data. So this transmitter will attach a start bit and stop bit to the data. Generally, the 8-bit ASCII format is used for transmission of data. So this 8-bit data is packed into a data frame. This data frame will have a start bit, then 8-bit actual data, and then stop bit. So the receiver will come to know when it will receive a start bit, it will come to know that now the transmitter is going to transmit a bit. Or receiver can synchronize its clock with the transmitter during that start bit. So different ways are there to pack this data into a frame. So example of asynchronous communication is UART protocol. So this you have to study for 8051. UART is universal asynchronous receiver transmitter. So it is asynchronous protocol. So clock is not transmitted along with the data, but data is converted into some fixed format data frame, and then it is transmitted bit by bit. So the data frame data is packed into the frame that we have seen. So this is the data frame which is used in UART of 8051 also. So assume that this is the data, that is ASCII value of data, ASCII value of data we want to transmit, the ASCII value of any character or bit. So this is the data D0 to D7. So this data we want to transmit from transmitter to receiver. So whenever we give this data to UART block of 8051, this UART block convert this data, 8-bit data, into data frame. So for that, it has to first attach a start bit. Generally, start bit is 0 bit, and here it shows the logic 1 signal. That means data is not transmitted by transmitter to receiver. So that is called as a mark. So the UART block will attach a start bit, that is logic 0, to this data. First LSB is transmitted to D0 is shown here. So after that, first it will transmit start bit, then LSB bit. So it will transmit all these 8 bits one by one. And to indicate stop of the frame, it will transmit a stop bit. So here one stop bit is shown, but stop bit can be programmable. It can be 1 bit, 2 bit, or 1.5 bit. So for each and every character number we want to transmit, UART block has to convert it into a frame, and then it will transmit this frame to the receiver. So this is to synchronize transmitter and reception. Now, this UART block uses RS232 standard, RS232 protocol for data transmission as well as for reception. So, this protocol was set up by Electronics Industries Association, EIA, in 1960. So the standard, it was developed in 1960. So they have used this different values for logic 0 and logic 1. The logic 1 in this standard is represented by -3 to -25 volt, whereas logic 0 is +3 to +25 volt. So since these levels are different than a TTL level of microcontroller uses TTL level. So 0 volt is represented as logic 0 and 5 volt is represented as logic 1. So these signal levels are different than the TTL level. So when we are using RS232 for data transmission, in 8051, we have to convert RS232 signal into TTL signal and TTL signal into RS232 signal. So to convert this signal, the MAX 232 IC is used. This IC works in both way. It converts the TTL logic levels into RS232 logic levels as well as RS232 logic levels into TTL logic levels. So for both this conversion, we can use MAX 232 IC. It is called as a line drivers IC also. This is RS232 cable. As I told you, our monitor is connected to CPU through this RS232 cable. It has a male connector as well as female connector. So these two types of connectors are shown here. So this comes under the standard. RS232 uses this type of cable. This is the standard. It uses the signals of value -3 to -25, +3 volt to +25. So these are the standards, the protocols. These are the rules we have to follow while transmitting or receiving data using RS232 protocol. So this cable we can use to transmit data. So this type of connector is also available on kit of 8051 microcontroller. So there we can insert this cable and then we can connect the other end of cable to our PC. So data can be transmitted from 8051 microcontroller kit to our desktop computer. On desktop computer, the different softwares are available, freely available, which are used to read a data from this communication port, which we call as a COM port, COM1, COM2, COM3, like that ports are available. So hyperterminal software is available, Terra terminal software is available. So through this software, we can read a data which is transmitted using RS232 to our desktop computer. That we'll see afterward. So this is RS232 cable. This is the DB9 connector. This RS232 connector, these connectors are called as a DB9 connector. So there are 9 pins available in RS232 or DB9 connector. So all these pins are used for the modem, communication with a modem. To interface modem, this RS232 protocol is used. So this pin number 1 is data carrier detect, DCD, that is used for modem. But we are going to use pin number 2, that is received data. So we will receive a data through pin number 2. Pin number 3 is for transmission of data, that also we are going to use to transmit a data. This data terminal ready is for modem. Pin number 5 is ground. So this also we want. All these data set ready, request to send, clear to send, all are for modem. So for 8051, we are going to use only 3 terminals, pin number 2, 3 and 5. Transmit data, receive data and ground. And these are the pin numbers, pin number 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 pin connector, it is DB9. So this is the MAX 232, how it is used. This is 8051, and as I know, you know that TXD is P3.1, that is port 3, pin number 2, P3.0, port 3, pin number 1, RxD. These are connected to T1 in and R1 out terminal of MAX 232. So whatever data it will receive from at this T1 in, that it will convert into RS232 signal. So that will be available on T1 out, that is connected to RxD, receiver terminal of this RS232. And other way also it can receive a data from RS232, convert into TTL. So this should be connected between DB9 connector and 8051. Same thing is shown here. This is 8051. These are the terminals of MAX 232 and then DB9 connector. So when you want to connect to 8050 microcontroller and you want to transmit a data between this 8051, this is one IC, and this 8051 second IC. So how these connections are done? The transmitter terminal of this 8051 is connected to receiver terminal. So whatever data is transmitted by this 8051, that will be received by second 8051. And whatever data this second IC is transmitting, that will be received by 8051 receiver terminal. So cross connection is used here. So whatever data is transmitted by one IC will be received by the other IC. And ground terminal is common. The ground terminal of both ICs is connected together. So instead of 8051, here you can use a PC also. We can transmit the data from 8051 to PC, or from PC you can transmit data to 8051. So this type of connections are generally used to connect two devices for serial transmission of data. Now, when we have discussed about mode 2 of timer, that time I told you the mode 2, that is auto reload mode of timer, is used to generate a clock signal for serial communication. So serial block, this UART block also work on some clock signal. So this clock for UART block is generated by timer 1 in mode 2. So timer 1 should be used in mode 2, that is auto reload mode. In this mode continuously work, no need to load data in count register again and again. It automatically works continuously. So because of this operation, it can be used to generate a clock signal continuously. So always remember that timer 1 in mode 2, that is reload mode, is used to generate a clock signal for UART block. Used to generate a clock signal means which will decide a baud rate. Baud rate is rate of transmission of data. So what is the speed of your data transmission? What is the rate of data transmission? How many bits are transmitted in 1 second? That is decided on this clock signal. And this clock signal is generated by timer 1, which is used in mode 2. So baud rate in 8051 is programmable. We can change a baud rate. To synchronize this asynchronous communication with other device, we have to synchronize this baud rate also. We can change the baud rate also. So in this diagram, it is shown that this is the crystal oscillator of 8051. We generally use 11.0592 megahertz frequency. This is divided by 12 by timer block. Now you should remember that the oscillator frequency is divided by 12 and then it is given to timer block of 8051. So if you divide this frequency, crystal frequency by 12, you will get 921.6 kilohertz. This frequency is given to UART block. The UART block divides this frequency by 32. First it is divided by 12. UART block again divides it by 32. We get a frequency of 28800 Hertz. This frequency is given to timer 1. Here it is written to timer 1 to set the baud rate. So divided by 12 by timer block, UART block again divided by 32 and then it is given to timer 1 28800 when you are using serial communication mode. That means when UART block is initialized, the frequency is divided again by 32 and that value is 28800 hertz. That is given to timer 1. Timer 1 is used in mode 2. Discuss about the registers we have to use for serial communication. The first register is SBUF register, that is serial buffer register. It is special function register. We have discussed special function register. It is byte-wise addressable register. You cannot read or write single bit of this register. So SBUF is serial buffer register. Now, whenever we want to transmit a data from transmitter to receiver, the ASCII value of character which we want to transmit should be stored in SBUF register. For example, suppose you want to transmit character A. Character A, I want to transmit using serial communication from one microcontroller to other microcontroller. So while transmission of any character, we have to use ASCII value of this character. And this ASCII value should be stored in this buffer register. Whenever user stores ASCII value of any character in buffer register, the UART block will convert this ASCII value into data frame and automatically it start transmitting one bit at a time. एका वेळेस एक बीट तो ट्रान्समिट करायला स्टार्ट करतो when we store ASCII value of character in SBUF register. So whatever character you want to transmit, its ASCII value must be stored in SBUF register. Now, how to store ASCII value in SBUF register? You can use this instruction. Move SBUF hash in single quote, you have to write that character D. For example, if you want to transmit character A, you can write move SBUF comma hash in single quote write character A. Here character D is stored in SBUF. So ASCII value of character D is 44H. Automatically, when you write character in single quote, this assembler will replace this character by its ASCII value. But remember that character should be written in single quote. Then only controller will understand or assembler will understand you want to store here ASCII value of character. So character should be written in single quote. So when we'll execute this instruction, 44H, which is the ASCII value of character D, will be stored in SBUF register. Now that the data of accumulator also you can store in SBUF. For example, I can write instruction move A comma A is accumulator here. Hash in single quote character A. And then I can use instruction move accumulator into SBU. Any way you can use, any method you can use. First store it in accumulator, then move accumulator contents into buffer register, serial buffer register. Or directly the ASCII value of character you can store in SBUF register. This is to store data in S buffer register. Automatically, microcontroller will start transmitting one by one bit, which is in SBUF register. When at the receiver side, this is at the transmitter side, we are storing data in receiver in SBUF register. At receiver side, when receiver receives any data, that will be stored in SBUF register. At receiver side, there is also SBUF register. So whatever data it will receive, that is stored in SBUF register. Now, when you want to read a data, you want to send it on LCD, you want to display it, or you want to process on that data, we can write instruction move A comma SBUF. So whatever data is received at receiver side, that is stored in now accumulator. This instruction we can use for transmitter side when you want to transmit a data, and this at the receiver side when you want to check a received data. So hope that it is clear to you. Now, as I told you, at transmitter side, we can transmit a data which is stored in SBUF register. So this is SBUF register for transmitter side. Assume that this is a transmitter and this is SBUF register. So whatever data we have stored here, that is converted into frame and that will be transmitted on TXD pin. At the receiver side, this data will be received on RxD pin. So there is SBUF register at receiver side. So this is a buffer register at receiver side. So suppose we are transmitting character D. So ASCII value of D is stored here and that is converted into frame that will be received by receiver and that will be stored in its SBUF register. So we have to write a data in S buffer register during transmission and the data will be received and stored automatically in SBUF register. At the receiver side, we can read it. We can store it in accumulator and process on this. Now suppose this microcontroller want to transmit as well as receive a data, full duplex communication or maybe half duplex. So this is also transmitting a data through this transmitter and it is receiving a data through receiver terminal. So for this, it is having two S buffer register. One S buffer register for transmission and second S buffer register for reception. Physically, there are two serial buffer registers in 8051. One is to transmit data and one is to receive data. I think you understood this. There are physically two registers, one to transmit and one to receive in each 8051. But for user, it is like only one SBUF register. Internally, there are two registers, but when you are using it, you are treating it as a one SBUF register. When you are storing data in register, internally microcontroller use this physical register. When you are reading data from SBUF register, it uses this receiver SBUF register. For user, it is like only one register. Only one address is given, that is 99H is the address of SBUF register. No need to remember address. We are going to use this name of register SBUF. This is the first register, that is SBUF register, where we are going to store ASCII value of character which we want to transmit serially using UART protocol of 8051. The next register is SCON register, special function register, which is serial communication control register, SCON register. So go through this bits of SCON register, SM0, SM1. These bits are used to select modes of serial communication. When these both bits are 0, 0, mode 0 is used. 0, 1, mode 1 is used. 1, 0, mode 2 is used. And 1, 1 means mode 3 of serial communication is used. You have to study mode 1 of serial communication. That is generally used for simple data transmission and reception. So we are going to use mode 1. So this bit should be 0 and this bit should be 1. So when we initialize SCON register, this bit should be 0, SM0, and this is 1. So we are using mode 1. SM2 mode is used for multiprocessor communication, that is mode 2 and mode 3. For us, it is don't care condition because in mode 1, this is not used. So we'll store here 0. Next bit is REN bit. REN is enable disable reception. The transmitter is always enabled. But when you want to use controller to receive a data, you have to set this bit to 1. If this is 1, you can receive a data. Always you can transmit a data. But if you want to receive a data, this bit should be 1. So even if we are writing a transmitter program, we'll set this bit to 1. For transmitter program, you can store here 0 also, but we'll set this to 1. Then these bits are again not used in mode 1. These are for mode 2 and mode 3. So we'll not discuss it. We'll store here 0. Now these two bits are important. These are interrupts bit. You might be remember the sixth interrupt of 8051 is related to serial communication. For both transmitter and reception, only one interrupt is used. But first we are discussing about the polling method. So for polling method, you can check this flag bits. So these are the flag bit. TI is transmit interrupt flag and RI is receive interrupt flag. Now what are these bits? Whenever the microcontroller completes a transmission of one frame of data, that means one character transmission is completed by microcontroller, automatically this bit is set to 1. जेव्हा एक ASCII व्हॅल्यू एक कॅरेक्टर ट्रान्समिट होतं कंप्लीट होतं ऑटोमॅटिकली मायक्रोकंट्रोलर TI बीट सेट करतो. So 1 is stored here. So after transmitting one character, user can check this TI bit. If it is 0, what it indicates? Data is transmitting. Data transmission is in process. If it is 0. If it is 1, it indicates that character is transmitted completely. Now you can transmit a second character. Hope that you understood this. So if it is 0, data transmission is in process. If it is 1, the data frame is transmitted. Now you can transmit other data. This is for transmission, so we have to continuously check this bit as we are checking a timer flag bit using JNB instruction. In same way, we have to check this bit. So initially it will be 0. We are not going to change this. Automatically after completion of one character data transmission, this bit is set to 1. This is the similar bit for reception purpose. When microcontroller received a one character completely, this bit is automatically set to 1. So while writing a receiver program, we have to check this bit whether it is 0 or 1. If it is 1, that means data is received. You can read that data from serial buffer register of microcontroller. But initially, we are storing here 0. So how will enable SCON register for mode 1? This is mode 1, 0, 1. This is 0. Receiver, if you want to enable, this is 1. And all other bits are 0. So if you convert it into hex, you will get 50H. Remember this value. SCON register should be initialized to 50H when you are using it in mode 1 and you have to study mode 1 programming. So this is the format of SCON register, and remember these bits TI and RI bit. TI bit, this is bitwise register. So you can read or write single bit also. So this TI bit is SCON.1 bit. SCON.1. This is second bit of this SCON register. So it is SCON.1, or directly in instruction you can write TI. The next register is PCON register. In this PCON register, we are going to use only one bit, that is SMOD bit. This is to change the baud rate of the serial communication. So SMOD bit can be 0 or it can be 1. By default, SMOD bit is 0. Means when you are not going to program this PCON register, it is 0. If you want to change the baud rate, you can set 1 to this SMOD bit. We are generally using this SMOD bit with value 0. So no need to initialize PCON register for baud rate. It has other bits also, power down mode, idle mode, so that we'll discuss afterward. But for serial communication, this SMOD bit of PCON register can be used. By default, it is 0, and we are going to use default value of SMOD bit. So we won't initialize this PCON register, but you must know how to change the baud rate. So these are the register, 3 registers we have seen. S buffer register, where we are going to store ASCII value of character which we want to transmit. SCON register, we have to initialize with 50H in mode 1. And to change the baud rate, SMOD bit can be stored as 0 or 1. By default, it is 0. The next is, before going to mode 0, we will use this mode 1 only. So mode 1 is simple mode. It uses TXD terminal to transmit a data, and it uses RXD terminal to receive a data. The start bit is usually 0. 8 data bits are transmitted. LSB is sent first, and the stop bit is usually 1 in mode 1. So simple mode which we have discussed, and we are not going to format this frame. Automatically UART block is going to convert data into frame. आपल्याला फक्त data द्यायचा आहे, internally frame format होते त्याची. So mode 1 is simple mode of this UART, that is universal asynchronous receiver transmitter. Now how to set a baud rate in UART bit? You can write this formula also. To find the baud rate in mode 1, the formula is 2 raised to power S mod. S mod is bit of PCON register. By default, it is 0. So 2 raised to power 0 means this factor is 1. Baud rate is 2 raised to power S mod. S mod is bit of PCON register. By default, it is 0. If it is 0, then this factor is 1. 2 raised to power 0 is 1. If it is 1, then this factor is 2. That means if S mod bit is 1, we are multiplying, we are doubling the baud rate because it will be multiplied by 2. 2 raised to power 1 means 2. Otherwise, it is 1. Then here division factors are used because frequency we are dividing first by 12 and then we are dividing it by 32. So this two data digits are used here to divide our oscillator frequency. This is the crystal frequency of oscillator, that is divided by 12 divided by 32, and we are using timer 1 in mode 2. In mode 2, timer is 8-bit timer. So how many counts, clocks it is going to count? 255 minus TH1. We are going to load a count in TH1 as per the baud rate. Try to understand this. This is the formula of baud rate. You have to decide a baud rate, rate of data transmission. As per baud rate, you have to find what count we have to load in TH1 register for the timer. So just remember this formula. This F oscillator is oscillator frequency, timer 1 auto reload value. Now there are standard values of baud rate. Whenever you will use a serial communication, standard baud rates are available like 1400. तुम्ही PC मध्ये पण serial communication ला बघू शकता. 1200, 2400, then 4800, 9600, and many other. Higher baud rates are also 1200. This is lower baud rate. This is moderate baud rate. We generally use this baud rate to transmit a data 9600. आपण कुठे पण किट मध्ये प्रोग्राम डाउनलोड करायला पण we are going to use this baud rate 9600. So for this particular baud rate, we have to find what values should be stored in TH1 register. So 9600 will stored in place of baud rate. So here I have shown some calculations. The baud rate is 9600, 2 raised to power S mod is 0 divided by 32. The frequency is 11.0592 megahertz, so 10 raised to power 6 divided by 12 multiplied by 256. It should be 256. 256 minus TH1. So solve this. You will get 256 minus TH1. If you shift it in this side, you will get it is 3. So TH1 is 256 minus 3, that is 253. If you convert 253 into hex, you will get FDH. So when you store FDH in TH1, the baud rate you will get is 9600. So data transmission rate will be 9600. These are standard baud rates. When you are downloading your program in microcontroller kit, that time also you have to select the baud rate for data transmission. So we are going to use 9600. So these are the calculations. You also try this. In TH1, you will get FDH. How these values are computed. That standard values you can remember for this. FDH should be loaded in TH1 to get a baud rate of 9600. Your baud rates, you will get these values. Now I'll see how to write a program. We'll write a program. So first check the algorithm. We want to transmit one character. Assume that we want to transmit one character from 8051 microcontroller. So we are going to write a program for transmission only. So first step is, these are the steps of algorithm. First step is you have to initialize T mod register. T mod register is timer register, timer mode control register. So we are using timer 1 in mode 2. So that's T-mod register we have to initialize in serial communication, because to set a baud rate of serial communication, we are using timer 1 in mode 2. So this is the format of T-mod register. So we are going to initialize with value 20. For timer 1 we'll use, timer 0 we are not using. So all these bits are 0, 0, 0, don't care condition. We are using mode 2. So here this should be 1, 0 for mode 2 of timer. We are using timer, so this bit is 0. We are using software instruction, so this bit should be 0. If you convert it into hex, you will get 20H. So to use timer 1 in mode 2, T-mod register should be initialized with 20H. So to initialize T-mod register with 20H, we'll use instruction move T-mod, comma hash 20H. So microcontroller will know we are going to use timer 1 in mode 2. So this will be our first instruction. The second is load TH1 register with the value of baud rate for serial communication. So we have seen in TH1, FDH should be stored. So to load this value in TH1 register, we'll use instruction move TH1, comma hash FDH. So that is 0 FDH. This is to set a baud rate 9600. दुसरा baud rate असेल तर हा data change होईल. For 9600 baud rate in TH1 register, we'll load this count FDH. Then we have to initialize SCON register. So for SCON register, these two bits are for mode selection. We are going to use mode 1. So 01 will store. This is for mode 2 and mode 3. This is to enable receiver. We'll enable it. If you don't want to enable, you can store here 0. These bits are used again in mode 2, mode 3. So these are 0. This we required, but we will initialize it to 0. So if you convert it into hex, you will get 50H. So SCON register will initialize with 50H. We'll use instruction move SCON, comma hash 50H. So SCON will be initialized. That will be our third step. After this, we'll start a timer. When you start a timer, the timer 1 will start generating a clock signal. On this clock signal, our serial communication block works. So to start this timer, we have to use TCON register, timer control register. So to start a timer, this bit should be 1, TR1 should be 1, all others are 0. This is auto reload mode, so we are not going to check flag bit and anything. We are not going to do anything. Just start the timer, automatically it will work, it will generate a clock signal. Only thing is that we have to set this TR1 bit to 1. TR1 is TCON.6 bit of TCON register. So we have to use set bit TCON.6. So to set this bit, we'll use set bit instruction. So start a timer. So clock will start generating. So initialization is done. We have initialized T-mod register. We have initialized SCON register. We have loaded count in timer 1 register. And we have started timer. Timer start झाला, clock start झाला. Now you can transmit a character. Whatever character we want to transmit, that we have to store in SBUF register. So which instruction will use? Move SBUF, comma hash, whatever character you want to transmit, write it in single quote. Suppose I want to transmit B. ASCII value of B will be stored in SBF. Or you can store this first in accumulator, and then accumulator data will be moved to SBF register. So immediately when you store ASCII value in SBUF register, Microcontroller, UART block convert it into data frame and it starts transmission because clock is already given to UART block. So transmission लगेच start होतं. What we have to do? We have to check a TI flag bit, whether it is 0 or 1. 0 means it is not transmitted completely. When it becomes 1, it indicates that our character is transmitted. If you want, you can transmit a next character. Before that, clear this TI flag, which we are doing in timer programming also. So check this TI bit. If it is 1, go to next instruction, clear TI flag. If you want, transmit other character. So just go through this. All these steps are written here. Initialize TMOD register with value 20H. Load TH1 register with value FDH in our case, depends upon baud rate. Initialize SCON register with value 50H. Then start the timer using this TR1 bit, it should be 1. Store the character which we want to transmit in SBUF register. Check TI flag bit, means monitor it continuously. We are using polling method, not interrupt method, using JNB instruction. And if TI is 1, clear it. And if you want, you can go back, but we won't go back. The same character, if you want to transmit, you can go back to this. Again, store the character in buffer register, check TI flag. If you want to transmit other character, then you have to add here step. Store character in SBUF, monitor TI bit, so continuously that can be done. This is to transmit a single character. We'll write first a program to transmit a single character to a receiver. So each step of this algorithm, I am going to replace by instruction. It is simple to write a program. If you know the process, if you know the algorithm, if you can draw a flowchart, you can write a program. First step is initialize tmod with value 20H. Why 20H? That we have already discussed. In TH1 register, load value FDH because the baud rate is 9600. In SCON register, we are loading 50H to enable mode 1 and reception also we are enabling. Start timer 1. So we are using set bit tcon.6, that is TR1. A comment we can write TR1 is equal to 1. The timer has started, clock start generating. I am transmitting here Y. I am not directly storing this ASCII value in SBUF. You can store it directly in SBUF, but I have stored this ASCII value of Y in accumulator, and accumulator contents I am storing in SBUF register. So once ASCII value of character is stored in SBUF, it will start transmitting 1 bit at a time serially. We have to just check whether TI is 1 or not. So jump not bit TI to L1. If bit is 0, not bit means if TI bit is 0, condition is satisfied, jump to label L1. L1 is again same. Continuously it will check whether TI is 0 or not. If it is 0, again it will exit. If it is 1, condition is not satisfied, so it will come out of this loop, and we know that data is transmitted completely. One character is transmitted completely. So we'll clear this TI flag so that you can transmit other character, or if any other user want to transmit data, he should be able to transmit it. So clear TI, and I'm writing here end instruction as jump here. So continuously it will jump here. Now, if you want to write a simple program, you can repeat these steps again to transmit a second character. परत second character मला YES transmit करायचे. So I will transmit character E next time. So what you have to do? You have to write this instruction again here. Instead of Y, you can write E. So store Y, E in accumulator, store accumulator in buffer, check this flag, clear this, then transmit it. But if your string is very long, this process is not proper. Okay, next lecture we'll discuss how to write this program for the string. When you want to transmit a string,